So one of the things that you'll see inside of Vantik as a development environment is we make it very quick to sort of build applications, but there are some other things that we do to make it, even faster. And what you're looking at on the screen right now is what is called the Vantik Accelerator. This is a blueprint, if you will, that many of our customers will start with and able to basically take in the blueprint and start with a digital twin of a smart building or smart campus related use cases. And what we've done here is we've taken a couple of the different CHOOCH models, taken the fire detection, the PPE detection, and the fall down detection, and in less than a day, outfitted this into the Vantic Accelerator. And so one of the things that you'll see here is you've got, as you can see, we've got a series of buildings, floors, and spaces. So I'm going to kind of show you how this works. I'm just going to close this out because we're going to recreate that issue. And so what we have inside the accelerator is essentially a mapping of a digital twin. Here you see we've got a number of buildings across a geographic landscape. If I drill down onto a particular building, you'll notice that buildings contain floors and therefore floor plans. And then going into a particular floor, floors contain both spaces, the allocation of space. This is the office, this is the hallway, this is the stairwell, as well as the assets that live within those spaces. So for example, if I were to look at some of the assets, and for here you can see this IP camera. If I view the asset, you'll see that it has a number of sensors, or at least one or more sensors, or streams of data is another way to think about what a sensor is. And so here you can see that this has the CHOOCH 980 model, which is the firearms detection model. So let's actually take a look at one of those models actually working live. I'm going to go over here to the main screen. I'm going to bring up the camera that is pointed in this office building. I'm also going to bring up a mobile view. So here we can see the phone at the same time. And in just a couple of moments, you will see that a fire is going to break out here in this particular office. So what's going on here is the system is recognizing, you've just seen a notification on my mobile phone, and the notification, as I pick it up, you can see it says fire alert. It looks like the live feed has not been updated yet. You should see that update in a moment. As you see the fire alert over here, and I open it up, you can see that it has detected the fire. It has basically said it's in the first floor records office. It's in the first floor on building 1. It's got the location and I could acknowledge it. You're probably also noticing that I'm getting a message or a phone call right now. If I don't have acknowledged the fire in a certain amount of time, then I've got this system placing a phone call.
A fire has been detected at building 1 at first floor at the first floor records office. Please address the situation immediately.
And so what you've seen here is basically a collaborative workflow that is basically using a series of escalations to not only identify and detect the fire, report it. One of the reasons that the fire is detected a few moments after is we've said, let's make sure this isn't an outlier and an anomaly or an anomaly. So we have told the engine to in memory analyze this and say, I'm not looking for one inference of fire. I'm looking for 6 or more in a row in a particular area. And the end of this particular story is that this particular building where we acquired this video from, because this fire wasn't identified soon enough, even though it was caught on a particular camera, this fire ultimately burned this building to the ground. And this probably couldn't have been avoided with just a burnt desk. This was a laptop that essentially exploded on the desk. Last thing I'm going to do here before I turn it over to Pat is I'm just going to show you a little bit of the back end. This is the application. Pat's going to take you over the personal protective equipment in a moment. And this is the application that is deployed to the edge. So this is the cloud application, the application that was built in the cloud. Pat will walk through this and describe it in more detail. But this application identifies the PPE conditions, for something missing, and then this PPE detection deployment basically allows us to tell the model where to go. So it's going to go to Boston and Colorado. So each of these is in a completely distributed location and push down this inference engine. And hopefully you've gotten a good sense of some of the kinds of capability of Vantik. I'm going to turn it over to Pat now to continue with the demonstration.
Thanks, Brett. Let me start my video back up. So we have put together a live presentation for everyone. This will be a brief live demonstration, and we'll focus on the safety and security aspect of the use case. So what I'm going to put up on my screen here, it's going to be a little busy, is a live view of the Chooch inference engine and what it outputs, which is running locally on my, my home network. A live view of Vantik, which is running locally on my home network. So these are the edge instances. And then I'm going to bring up my Vantik mobile device on my mobile phone, just as Brett did. There you can see the fire alert he just created, so that we can see these notifications come in real time. And the point of this exercise is just to show everything working all at once, so we get an idea for what running this in a real environment really means, and why we run it at the edge as opposed to just pushing everything up to the cloud. Okay, so I'm going to go ahead and start my camera. My camera is based on motion detection, so it'll take a second to fire up, and once it does, we'll start feeding information into the Chooch engine, which is a real nice feature. So if you have a camera that goes to sleep, when it wakes up, Chooch will just immediately start processing it, as you see here. So for our PPE demonstration, we could have tackled this a couple different ways. One of the ways would be what I consider the green lighting scenario, where you have a person who steps in front of a camera, they put on their safety gear, or they already have it on, and then they get greenlit to go into the work environment. The engine that we're using from Chooch, the PPE engine, can detect things like safety helmet, vest, gloves, mask. So we can apply this to a number of different use cases and solutions, even things like just normal lobby detection, where we want people coming into the office, making sure they're wearing a mask for COVID safety. And then we can green light those people. The way we've adopted the use case for this presentation is we assume that we're monitoring a field of view, like a construction site that already has people in it. And we're looking for violations in safety gear, and then we're going to be alerting the foreman in real time. So let's say we have someone out on the site and they take their hard hat off because they're eager to show everyone their COVID hair. And what will begin happening is that the Chooch engine will start to detect hard hat alerts, but that alert isn't going to be generated right away. And this is intentional. So what we've programmed into the application logic is a certain number of consecutive readings that have to occur before Vantik actually triggers the hard hat notification and the PPE alert, which you just saw. And this is so if there's an obstruction in the view, or someone takes their hat off for just a second, puts it back on, we're not triggering a continuous stream of alerts. So we're able to toggle the logic a little bit in order to prevent that. And then on top of that, we have one camera that's running multiple inference engines. So this camera is actually running the PPE engine, it's running fall detection, and it's actually running fire. Now, I can't actually generate a fire in my home office here. It's not desirable. So I'm going to go ahead and trigger a fall down alert by falling down. And again, the triggering of the alert is based on a number of consecutive readings. We capture the image itself, and we send it into Vantik. And you guys can see on my mobile phone here that these notifications have occurred very quickly and in real time. Now, as part of a real world environment, here we probably don't want to instantaneously trigger any kind of alarms or alerts. So what we're giving is the site foreman an opportunity to review the information. Maybe they're on site, maybe they're off site, and use their human intuition to determine whether this is a serious safety issue or not. Now, in Vantik, we can build very complex remediation workflow, as Brett was showing you, the phone call for the fire and stuff like this, so that our actions can be based on a number of acknowledgements or third-party system integrations, creating tickets, stuff of that nature, so that we can ensure that we're in safety compliance, whether it's a corporate compliance, whether it's COVID-related compliance, or whether it's OSHA compliance. We provide the information to the users who need it, and then allow them to take the appropriate actions. So we're using the computer vision system in this case to help supplement human decision-making in a way that is very real time, so that as these problems unfold, they don't become more serious. So as I mentioned, all this is running at the edge, and because of the way that the Chooch system works, we can then easily expand this into other use cases. For example, if we wanted to add social distancing, or we wanted to add firearms detection, or some other capability, we could easily incorporate that into our edge deployment through the way the Chooch is set up and configured, which I'm going to show, and through how Vantik does application development and deployment, which I'll show a little bit as well. So we can start with a simple use case like fall detection and really expand our system with the same equipment, same cameras, same edge computers, and take advantage of those for additional use cases. So I'm going to walk a little bit backwards from the end application that you just saw, which is the PPE and fall down detection and alerting, through the initial deployment, so that you get a feel for what a real world deployment looks like from a bit of an end-to-end basis. So what we're doing here is really doing all our business logic that you see at the cloud side. So all that information is coming in from Chooch, and I'll discuss how we get information into each system. So from Chooch into Vantik at the edge, and then we start to process that information and look for those different scenarios, like fall down or missing safety equipment. And then we take the relevant information and we send it up to the cloud. And what this means is at the edge, there's a ton of transient data being generated that isn't being sent to the edge. So we don't have to worry about bandwidth or latency concerns with that. All the vision processing and then all the heavy data processing is going to happen at the edge. Now in the cloud, Brett showed you what we call our Vantik Accelerator. And the Vantik Accelerator is a template project that we've created that we offer to our customers for free that provides a starting point for this digital twin type interface. And in this digital twin interface, we can easily onboard, in this case, sensors, which are your devices. These could be cameras, these could be other type of sensors. And then we can incorporate them into a digital twin interface. And that could be taking advantage of many different things. So for example, if you wanted to do location tracking of a person, you could have a BLE sensor. Those BLE sensors aren't necessarily that accurate. So maybe we're going to increase the accuracy of the BLE with the computer vision AI engine. And then we can put all that into this digital twin, and we can in fact do live tracking of that through this interface. So we have actually, these badges representing people. We could replace this with a more sophisticated 3D model. And in some of our use cases, we've even replaced this with 3D models of different objects, people, vehicles, stuff like that. So if you have privacy concerns about using camera data, the camera data in any imaging could just be completely thrown away or not generated at all. And then we can actually enhance our perspective using digital twin interface through the computer vision system or through combination of other systems and sensors that you might include in that environment. So that's how we would address things like PPI and privacy concerns. And there's other technologies out there that we can take advantage of, like face blurring and stuff like that. All right, so additionally, since all the critical alert information is going up into the cloud, we can store that information and we can use it for some historical analytics. And here you see, because we've been running this demo quite a lot lately, we've had quite a number of fires going off in our buildings. This is a very unsafe environment if you're looking at this chart seriously. But what we're able to do is capture those events, allow someone to go to a dashboard interface and review the historical information, previous incidents that have occurred, as well as historical incidents. And the value of the historical information is knowing where problems occur and what type of problems occur. So if this is a field situation, or if this is an indoor scenario, or maybe it's even a COVID scenario and people are trying to sneak by the desk without masks, we'd be able to isolate where those issues occur most frequently, what types of issues, and then we can go and try to address those problems to reduce it and make our workplace a more safe environment. So that is the application front end. So we do assume that most people won't be sitting here staring at a dashboard waiting for these issue alerts to come in, which is why we rely on mobile alerts which we've shown you coming in the form of push notifications, but we can also do text alerts, SMS notifications. You saw the phone call coming from Brett, email alerts, whatever type of alerts you want. And those remediation workflows can vary from very simple to very complex. So now I'm going to get a little bit into the system setup and how this thing got built and deployed. So from a Vantik perspective, everything we do is developed in the cloud. Earlier, I was showing you a view of Vantik, really a developer view of Vantik in my local environment. Now I'm showing you the same thing in a cloud environment. And when we were building this presentation, this is where Brett and I would go to develop the actual application logic. And what's kind of neat about this is you guys see this GUI application here. And I know you're probably thinking it looks a little bit like business process management or data flow. But what it really is a GUI representation of event-driven applications. So each of these little blocks and diamonds that you see represent chunks of code, which we call procedures. You can think of them like functions or Lambda functions that are executed whenever an event comes in. So when the Chooch inference engine sends us a message, that triggers the code execution. And this all happens asynchronously. So we could have 50 cameras sending us messages all at the same time, and that would initiate 50 code executions at that first layer all at once. And that's sort of the basis of event-driven architecture and how serverless systems work, because your resource utilization expands and contracts based on how many events are coming into the platform. Now, in this GUI application that I'm showing here, there's a combination of pre-written code that is provided by Vantik that provides some programming logic that's very common to event processing, like filtering and splitting messages and unwinding arrays. And then we also supplement that with code that we write ourselves and that we work into here. So anytime we need custom business logic, we just write the code by hand and then we incorporate it into this GUI application. And this is what ends up getting deployed to the edge. Now, these arrows here don't actually represent business process flow, as I mentioned. What it really is showing you is an outgoing event that is being published, and the next stage, the next application stage, is subscribed to that event stream, which is causing the execution of that downstream event. So that's the visualization of the event-driven application model, which is kind of neat. And what that means is you can have multiple subscribers from a single publisher, just like any pub sub system, which is how you see something like this no hard hat splitting into two directions. So we can have multiple asynchronous operations going, like a database write that's happening on one thread, while on another there's a business analyst looking for certain text, like we are in the Chooch message. So that's how Vantik works at its core. And we take advantage of this sort of graphical interface to do very complex things, like combining the Chooch AI inference engine data with something like a BLE badge tracker to create that highly accurate location tracking, which we then put into the GUI client, which is also built through the Vantik interface, which we're not going to get into for this presentation. Okay, so for the actual deployment, here's how it works. On the Chooch and Vantik side, we both offer a MQTT connection. An MQTT is a message broker. It acts as a sort of publish subscriber middleman between a lot of IoT devices. These days use it in other type of systems. And we are using it because both systems provide that out of the box and allows us to take advantage of a very simple way to connect to each other. So what we do is, on the Chooch side, we have a configuration interface that allows us to specify the MQTT broker we want to send to. Now, there is no MQTT broker at the beginning of all this, right? There's nothing. There's no Chooch, there's no Vantik. The edge is just a system that doesn't yet exist. So we provide an alias. We call it mqtt.local. And then we also need one more piece of information to get this to work, which is the IP address of your camera stream, which you can see here. And then you can add the models that you want in for that camera stream. And all this can be fully automated with Chooch through the REST API. So the onboarding process for a new camera could be as simple as punching in the IP address into a mobile app, and all this gets set up for us. On the Vantik side, we do something very similar. we have what we call source connections, which allow us to connect to something like an MQTT broker. And then it's obviously not running because this is the cloud and the MQTT broker is going to get deployed to the edge, but we use the same credentials, right? We have the same MQTT.local alias. And this is going to be how the information gets from Chooch to Vantik. So the next part of this is to actually deploy these systems and set them up and start them running. And because Vantik and Chooch both provide Docker images, we can do this whole thing with Docker. So the way we've configured Docker is we've got an environment that includes the Chooch image, the Vantik image. This is an example of the environment that we use for Chooch that's currently not running on my laptop here. We have Mongo, which is the persistent storage layer for Vantik, and then we have Mosquito, which is the MQTT server. In our Docker configuration, we simply give that Mosquito server the host name of our MQTT alias. And that way, when I turn this on, Chooch can talk to it immediately, Vantik can talk to it immediately, everything's set. So the deployment process itself for, say, an enterprise IT environment would be to use something like Kubernetes, some enterprise level container management system to deploy these images in this particular configuration. And when they go out, they're just automatically up and running, which is a really nice capability. So the deployment for the application logic still has to be done. Vantik, Brett showed you, has a deployment configuration. The PPE one is very simple. It just has the PPE logic. When I want to deploy to all my edge instances, in this case, we just have two, Brett's office and my office, but I could have hundreds of them. I just hit that deploy button. And the onboarding process for additional locations is based on like a tagging system. So I can give them all a tag like edge device, and it'll deploy to all those edge devices, whether it's one or whether it's 10,000. Now that application logic has been deployed there. And because Vantik is also REST addressable, this entire process can be fully automated as well. So the onboarding of the underlying images, the onboarding of the application logic, the connection between the systems through the MQTT broker can be 100% fully automated. The only thing we need to provide is the edge systems itself and a connected, IP camera.
Vantik. Innovate faster. Operate smarter.